Hello friends, welcome back to my channel. In previous lecture we studied the purely resistive circuit, analysis of purely resistive circuit, in that voltage and current waveform, vector and average value. Now let's see purely inductive circuit. In purely inductive circuit, ohmic value of inductor is 0. Hence it is represented as single inductor having a coil, purely inductor L, supply is V is equal to Vm sin omega t. Current flowing through inductor is represented by I of t. So when this alternating current is flow through that inductor, an alternating magnetic field is created around that inductor and it induces the EMF in that inductor. That EMF E is opposite to the supply voltage by Lenz's law. So E is equal to minus L di by dt. This is first equation. Secondly, it opposes the supplied voltage. So V is equal to minus E. Second equation. So we can write it at V is equal to minus E, that is L di by dt. So L di by dt. Equation number third. We have to express the equation for current. Hence di by dt is taken one side. Di by dt is equal to V upon L. Now V is Vm sin omega t. So here Vm sin omega t divided by L. We have only I, so we have to cancel out this di by dt. And to cancel the derivative term, we must integrate on both sides. So integrate on both sides. Di by dt get cancel out, it becomes I is equal to integration of Vm upon L sin omega t. Let's integrate. Constant term is taken outside, Vm upon L. So integration of sin omega t. So integration of sin omega t, integration of sin t is minus cos t, and here instead of t there is a omega t. So we have to differentiate it again and divide by it. So my Vm upon L sin omega t is minus of cos omega t, and again differentiate and divide. So omega t, differentiate omega t, we get omega. So minus sign, minus of Vm, minus Vm upon L cos omega t. This omega is write down here omega. So minus Vm upon L cos omega t is equal to I. We have considered sign in voltage equation. So because of this we have current expression in terms of sign. So sin theta plus or minus pi by 2 is equal to plus or minus cos theta. So here minus cos omega t means sin theta minus pi by 2. So I is equal to Vm upon omega L sin theta minus pi by 2. Omega L, omega means 2 pi f and L. So omega L we can write it as a XL, that is inductive reactance. We already discussed what is inductive reactance. So I becomes I is equal to Vm upon XL sin theta minus pi by 2. This is expression for current in purely inductive circuit. Unit ampere. Ampere. And expression for voltage VL is equal to Vm sin omega t. So we get two expression. V is equal to Vm sin omega t. So we have to consider Vm sin omega t means it is taken as a reference, and here minus pi by 2. Minus pi by 2 indicates that it is a lagging phase difference. So we conclude that in inductive circuit, I lags V by an angle of V is equal to Vm sin omega t, and I is Vm upon XL sin omega t minus pi by 2. So here it is lagging by pi by 2. So pi by 2 means 90, means current waveform start after 90 degree. So 90, from 90 degree it start peak value. So peak value for current in inductive circuit is Vm upon XL. This is a peak value for current. So here Vm upon XL. So always draw this is maximum, but for current waveform this portion is less because Vm by XL is current, and this phase difference is pi by 2. In radian pi by 2 and 90 degree or 90 degree. So next is vector representation. Vm sin omega t is taken as a reference, means it is at 0 degree position. So this is for voltage, and current lags voltage by an angle of 90 degree. So 90 degree means exactly perpendicular. So this is vector representation for current, and length represents RMS value. So this is Vrms, Irms, and exactly 90 degree. This is phasor representation.